The next speaker is also an industry speaker, and there we are. The topic is a call to automate automation. He works for ABB. I think many of you know that ABB has been engaged in robotics for some time now. Our speaker, Thomas Fuhlbrigge, leads some of the next generation robotics work with ABB, and I'll welcome you to the stage.
Thank you. Thank you very much. Okay, so thank you for inviting me to this program. It's really interesting so far. I'm enjoying it quite a bit. So for me, what I wanted to talk about today was the need to essentially automate the automation, right? And I'm going to kind of establish why we have that need right now, and then some things that we need to solve to actually start accomplishing that. So this here, what we see, I have a picture of, a bunch of ABB robots, but the classic, like what we call automotive style robotic automation, okay? And it's very high density, very complex, okay? Really high quality output. I mean, that's why automotive does this, for the quality, right? But other things is that it's got like a 8-year line lifetime. That's what we designed for. It's an 8-year lifetime for those robots on that line. In a plant like a body and white plant, where you make the car shell like this is, there'll be about 600 robots and very few people. People are just there to take care of issues, right? They're not there to actually synchronously do stuff for the production. But it's expensive, but the ROI for them is great because it's a long lifetime and they produce a lot of cars. And the focus for them lately, the past 5-10 years, is to be able to run a lot of models through. So this particular line can run like 8 different cars through that line. And then currently, we do some collaborative robotic automation, and the Yumi is our kind of ABB example of that, right? It's an inherently safe robot, very light, people-sized, people-speed. But on the other hand, it's quite lightly engineered, with the cells that you do with it. You're still looking for a high-quality output. Not as much cost there. It's much less expensive. Generally, the line lifetime is short, okay? What you're doing is something that is a pretty short time frame. It's not that complex. You have a lot of people usually involved. It's a collaborative thing. Not so many robots. So, but what you can see coming is that, the future collaborative automation will be taking things like this DioNet factory, the install that we have in Eindhoven. And here, just a picture I got from the web, is the Moto X Factory in Fort Worth, Texas, right? They have the costs where they need to automate, but they're not doing it currently, right? So what you can see, there's a strong need for a lot of robots. And you can imagine, especially in like the larger small part assembly factories, they're doing consumer products like Foxconn and those kind of people, right? Where they have tens of thousands of employees building stuff in the same plant, that there's going to be need for thousands of collaborative robots within the same plant, okay? And it needs to be much more high density automation. Well, and one more thing, what's going to push this automation? There's some really, really strong demographic and some economic factors going on. In most of the world, there's actually a very strong decrease in the available manufacturing workforce. One of the interesting things here is this graph that I got from the China Daily, showing the expectation that between basically now and 2050, so over the next 20 years, China's going to lose 200 million people out of their workforce. So that's essentially the workforce of the United States coming out of their workforce. So they have a strong need to, if you want to keep up the GDP, keep up, the lifestyle, right, what people are used to, you're going to have to automate, okay? We also see in the Western world, especially these stricter immigration policies, which are, preventing the immigration of workers that are willing to do factory jobs. We see the high worker expectations. Everybody wants an office job. If you brought your kids up in the Western educational system, they don't want to work on a factory line, right? They want to be an engineer or a doctor or a lawyer. They want to do something that is a normal office job. And of course, the rising labor costs in low-cost countries. So those are kind of like the workforce issues. But then, positively, we have these, increasing computer literacy. There's an expectation of automation. People, You know, they're used to their phones, right? They're used to the computers. They're used to interacting with machines much more. So there's an expectation of automation in all the younger generations. And then we're finding that the open source movement is really changing the cost drivers in that a lot of times you don't have to capitalize your R&D. You can simply download these, you know, like machine learning has been fantastic lately because the best machine learning algorithms are the open source ones right now. So, you know, it's really fantastically helping out. So what's the problem? Let me give you a quick little example of a problem that we had within ABB. So this is a little push button that ABB makes, you know, simple thing, not very many parts. You know, generally they make these in a 250,000 batch, essentially, which is about 4 months of production, okay? It takes about 20 seconds to make one of these things. When they went to automate with Yumi doing this little clip insertion, which is this clip here, okay, they kept track of what did they do to, and what was the time, where did they spend their time, right? What was hard, what was easy? What's really interesting about this is that 4% of the time was spent programming the robot, okay? About half their time was spent kind of getting things ready. But where it really was difficult was this process robustness and tuning. And that's trying to get the quality up, right? Trying to get the assembly to happen all the time, basically, right? You need to get, you can't be right 90% of the time. You have to be right 99.999% of the time, essentially. That's what your goal is to rarely ever have failures. And if you do have a failure, to be able to detect that and set it aside. So the problem is that the methods that we have today for programming and interacting with the robots and getting things set up, they really don't scale, right? Because every time you take a cell like this and you want to do something different, you want to change over to something else, right? I need new grippers, I need new part feeding stuff, the bin trays and conveyors. I need to train the vision system again. I need to do new assembly sequences. I need to do, you know, all the programming over again. And then really what I have to do is I have to sit there and watch this thing in production and tune it so that we get the speed that we need and we get the throughput that we need, right? We need that robustness. And you can only do that robustness in situ, right? If you do it off to the side and then kind of transfer it in, it's different. Everything's a little bit different, right? And all these things are just little tiny friction problems or little tiny misalignments. It's all small stuff, right? But it just takes time to sit there and figure it out. So how do we change that? How do we make these things scale? How do we improve the, you know, how we can automate, right? Well, we have these enablers. So we have sensing hardware, right? Of course, we're using 3D vision. A lot of computational power is now available at the robot, right? You have your NVIDIA stuff, right? We're making use of augmented reality and virtual reality. And then the machine learning is really important, right? Being able to recognize the parts on your own, being able to gather the experience of the production, and then really to self-optimize for quality and speed. That's something that the robot can do, because it knows when it's wrong. If it's done assembly wrong, it's pretty easy to tell. Like you gripped it wrong, you lost it out of the gripper or whatever. And then really these general purpose adaptable grippers, right? It's really a pain to have to change the gripper around every time you're changing the part a little bit. So right now, what parts of the automation can we automate? Where do we see kind of like the shorter term stuff that we can do, right? That can get the robots to set themselves up and then self-optimize, right? So, and this isn't holistic, right? This is just a partial list. These are things that are kind of clear needs, right? I mean, robots, they need to map their local surroundings, right? They need to know what's around them, right? They need to identify their parts, they identify fixtures, they identify all the things that, like all the nouns of the system. And then just avoid hitting everything else. It's like a child, right? You know, when you got a little kid, right? There's all this stuff going around, all of a sudden he'll point out and go, tractor. You're like, where? Oh yeah, there it is, the tractor, way, a quarter mile away. But he knows certain things. A robot needs to know only a certain number of things, right? It doesn't need to know everything. It just needs to know the things that are important to it, which are the parts and the fixtures and whatever tools it has. It needs to interpret the local assembly graph, right? Whenever you're doing manufacturing, you have the assembly graph. Part A and B go on carrier C, right? That's that's like the classic thing. You're putting two parts in another part. It's part of the planning for doing a line, right? It's available to the robot. It could figure out what the program is, the sequence of events within its own cell, just by giving it the assembly graph. You know, that's a really approachable thing. Figuring out how to pick parts and assemble them. So basically, how am I got these parts, and they're whether in bins or they're in trays or they're coming on some sort of feeder. Where are they? How do I pick them? Let me practice picking them. Just get that subset of those things down, so I can get something, at least I know how I'm gripping these parts, right? And then once I figured out how to grip them, okay, how do I assemble them? And that usually, that last inch of motion is really always the tough part, right? It's easy to pick the parts, it's easy to get close, right? Automated wise, but getting that, what is the actual assembly process is quite hard. And that's where, you know, if you need to ask the operator for help, ask for it in a very specific way, right? Something that is intuitively obvious to a human, right? You know, you say like, can you show me how to get the clip in, you know? Because it's just that, you know, the robot may not be able to figure out where does it actually go. It knows that these two need to go close together, but how do I actually get that last inch of motion is often the critical thing that a person can provide, and may only take like 10 minutes to do, rather than spending, you know, days with the robot getting everything else set up. And then clearly, like I said before, self-optimizing for robustness and speed, right? Practice. When people are doing these operations, you know, often they're not very fast, right? When they start this thing out, you explain to somebody, they start doing it, and you'll see that, you know, first day they're really focusing, and then within 2 weeks they're doing the assembly process, and they're looking around having detailed conversations about other topics with people not even close to them while they're doing this process really quickly in a high quality way. People learn and they, you know, convert it into their muscle memory, right? But they self-optimize for robustness and speed. The robots need to do that too. And then share and use the experience, right? So the robot should be able to say to, you know, somewhere in the cloud, hey, has anybody put this part together before? Has this been done? You know, does anybody recognize this or have these parts? What are they? You know, what? Or here's my experience on how this part goes together. I need some way to organize that and store that somewhere so that other robots can make that available or have that available to them. And that's it, right? That's, you know, the goal, right? Automate the automation. So what I talked about was, you know, we do a lot of automation now. We have collaborative robots coming where there's going to be a lot more, you know, numbers of robots in a tighter area with working together with people. But, you know, what I said is that the way we do it traditionally now, it just doesn't scale up to large populations of robots. So we need to figure out how do we enable the robots to do more of the things on their own. That's it. Thank you.